Let's take a moment and talk about data types in general before we get into the specifics of how MySQL represents data with its data types. Data types are important because they're how the database stores and represents its data. If you understand the data types, you'll have a much easier time working with the data. MySQL has data types for numeric data, for representing numbers, string types for storing words and text, large storage types for storing documents and files, date and time types for storing date and time values, bit values for storing logical values and flags, and enumeration types for mnemonic values. MySQL has a rich set of data types. This chapter covers the most common and useful types, and if you're interested in knowing the full breadth and depth of what MySQL has available, please see the documentation on the MySQL website. There are three major kinds of numeric types: integer types, floating point types, and fixed point types. Integer types are for storing whole numbers, that is, numbers that don't have a decimal point or a fractional part. Numbers like 1, 2, 3, and 4. Floating point types are for storing real numbers, numbers like 3.14159 or 147.39. Use floating point storage for applications where the range of mathematical results is more important than the accuracy of a calculation. Fixed point types are for storing decimal numbers that have a fixed precision. This is a special type that is useful in situations like financial applications, where arithmetic functions must return accurate results rounded to a specific number of digits. The distinction between floating point and fixed point types is very important, so let's take a look at an example. In the test database, you'll find a table called numerics. I'll type describe numerics, and that will give us the structure of the table. It has an ID field, and it has 4 numeric fields, 2 decimal and 2 floating point. The decimal types are DA and DB for decimal A and decimal B, and the floating point columns are FA and FB for floating point A and floating point B. There's one row of data in the table. And you'll see it has 4 values, 0.1 and 0.2 in decimal, and 0.1 and 0.2 in floating point. The decimal values have the decimal point in a fixed place and a fixed number of digits after the decimal point. The floating point numbers do not have a fixed number of places after the decimal point, so they just show 0.1 and 0.2. Now, if we take the decimal values, DA and DB, and add them together, say DA plus DB, you'll see we get the expected result. DA is 0.1, DB is 0.2, and DA plus DB is 0.3. Now, if we test this for equality with 0.3, in other words, we're testing the result of DA plus DB against a literal value of 0.3, we should get a true answer. And true would be 1, and false would be 0. So we expect to get a 1 here. So this is what we expected. DA plus DB equals 0.3 is true. Now let's try the same little experiment with the floating point values. Take FA and FB, which are 0.1 and 0.2, and we'll take the sum of FA and FB, which is 0.3, and we'll test it against 0.3 and see if that comes out as true. We notice in this case it is false. 0 means false. We might say, well, if FA plus FB is not equal to 0.3, what is it equal to? Well, let's just take out the equals 0.3 part here and see what FA plus FB is. And that's not really what we expected, is it? It's 0.3, which is accurate to about, 6 or 7 decimal places, and then a bunch of junk. This is not equal to 0.3, and that's the problem. Floating point numbers in all computer systems, not just in SQL, but in all computer systems, floating point numbers sacrifice accuracy for what's called precision. In the mathematical world, precision means something different than what you might think it means in your average colloquial speech. In the mathematical world, precision refers to the number of digits of accuracy. So it's accurate to 6 or so decimal places, but beyond that, it is not accurate anymore. Floating point numbers sacrifice accuracy for what they call precision. Decimal number systems in computers are specifically designed to limit the precision for accuracy. In other words, they will always be accurate to the number of decimal places that you define them to be. You will use specific rules for doing rounding, and this works best and was designed specifically for monetary applications, for applications where money is involved. If you're a designer and you know the difference between JPEG and GIF files, think of this like the difference between JPEG and GIF. JPEG files are great for photographic data, but they sacrifice the precision of the colors. They give you the access to millions of colors, but they sacrifice the accuracy of those colors for the amount of colors that you get. GIF files, on the other hand, great for flat artwork where you've got a limited number of colors because they will very accurately represent up to 255 colors and no more. That's the difference between floating point and decimal. Fixed point types are like the GIFs. They have a limited amount of precision and they are very, very accurate. Floating point types are like the JPEGs. They're able to represent a wide range of numbers and they sacrifice a bit of accuracy for that. This distinction is very important, and the point is, of course, if you're doing monetary applications like banking or accounting or anything like that, make sure that you use the fixed point types, in this case decimal. String types are for storing strings of data, often text. Fixed string types are for storing text that's always the same size, like a 2-letter state code or something like that. Variable length string types are for storing strings of values that might have different sizes, like a name or an address. Character string types are for storing textual data, and I pronounce C-H-A-R, char. Some people say char. Char is the fixed length type, and varchar is the variable length type. Binary types are for non-textual data. Binary is the fixed length type, and var-binary is the variable length type. This is the create table statement for the album table in the album database. You'll see we have an integer type for the ID, and we have varchar for title, artist, and label. In parentheses, you put the maximum length of the variable character field. So we have 255 for all of these. And then we have a date type, and we'll talk about those later. So this is an example of this in use, and this is usually how you'll see it used. Every once in a while you'll see char for fixed length ones. You'll very, very rarely see the binary type or the var-binary type. So string types are for storing strings of data, usually text. Blob and text are large object storage types, binary and text respectively. Blob stands for binary large object. It's used for storing data that is not text. There are 4 types of blobs in MySQL. Tiny blob for storage up to 256 bytes. Blob for storage up to 64,000 bytes. Medium blob for storage up to 16 megabytes. And long blob for storage up to 4 gigabytes. And these are all for non-textual data. For textual data, we have the text types. And likewise, they come in 4 sizes. Tiny text for up to 256 bytes. Text for up to 65,535 bytes, which is 64K. Medium text for up to 16 megabytes. And long text for up to 4 gigabytes. The blob types are useful for storing binary objects like images. The text types are useful for storing text objects like articles or web pages. The text types can be used with MySQL's full text searches.